Hello, I'm Eric Snodgrass, and thank you for watching today's in-depth ag forecast video brought to you by Nutrien Ag Solutions. First of all, I know I'm coming to you a little bit later than normal. I spent the day at the Professional Dairy Producers Conference in Wisconsin, and I got home and I had training to become recertified as an official coach for kids soccer. So we just got to it now, but I'm ready to record this video. Also, another quick change, because I'm releasing videos every morning in my morning reports, I'm only going to start doing one long-range video every Monday and Thursday night, and since we're through most of the growing season in South America, we're just going to tack on South America at the end of these. So just a little change coming for you. If you'd like to receive that morning report, it's something that we do at Nutrien for free. You can just email me. I put my email right here in the comments, so you can contact me if you'd like to get signed up for that. Anyways, you've been staring here at the latest drought monitor, which was updated today, and we didn't see too much of a change in this overall map with the latest release. I still expected to see better improvement across this area. We might continue to see that. But as I was looking at this afternoon, I started just thinking back about how long we've had the drought monitor around, and can we use it kind of as a historical analysis tool to kind of try to find some sense of an analog for this year. And that's proving to be quite challenging. I'd like to show you why. I made a little movie for you, and it's going to show you in early March, every year since we started the drought monitor, which is in the year 2000, on what the drought monitor looked like. Now, this is going to play relatively quickly here, but what you're going to see is that as we go through the early 2000s, all right, we did have quite a bit of drought in the West at times. But if you just look at this, there were several years, like, well, let's just pause it there. That's a year that a lot of people are thinking a lot about. This is 2012. If you'd like to know what the drought looked like at this point in 2012, we had it lingering from 2011 here in the Southern Plains. And of course, we had drought building in the Southeast. But what's interesting is this drought picture does not look like what we have this year. Let's get to this year. As we keep playing through the 20-teens here, what you're going to see is, in fact, let's pause it one more time. 2019, that was about the least amount of drought we've seen ever in mid-March across the United States. But as we get toward the end here, the one year that looks most similar to this year was last year, which was 2021. So that's what 2021 looked like. There's 2022. So when I tell you that this is really a unique view on drought, when at least looking back over the last 22 years, that's what I'm talking about. So I'm thinking about this specifically for the Central Plains right now, and also the Northern Plains up into Montana. We've covered the West Coast from Oregon to California and Nevada. We know that because of this La Nina, the likelihood of developing any sense of a subtropical jet stream has been limited, and we've covered that in a few different videos. I'd like to come now to the plains right here and have a discussion about what we're going to be seeing moving forward. So right now, we've got a great scenario. There is going to be a sizable low pressure system that's going to come out of Colorado early next week. And this whole region that you see showing up here in green is all going to be above average precipitation. Now there's an issue with this. Because of how far to the south this trough digs, we are not going to be seeing above average precipitation for the Northern Plains back into Montana. Again, that is a region we desperately need to see more rainfall. But we need it in through here. Unfortunately, we're going to get flooding on the eastern side of this and through this area due to how much rain we're going to get. And this is going to push through states of Iowa, Illinois, Wisconsin, and Michigan on its way up into the northeast. So just thinking about that, I want to give you some numbers first. We're going to go right to the 12Z European model, and let's just play this out. So we have the system that's currently moving through right now that basically Friday through Saturday runs right here through the Midwest. So this is total precipitation through Saturday afternoon according to the European model. So look, we're adding in parts of Kansas upwards of an inch of rainfall. Okay, that's system one. All right, system number two, here's where it shows up. This is next week, so Monday, Tuesday. And if I just let this go all the way out 1 week, there's the potential from the southeastern corner of Nebraska through most of Kansas, parts of eastern Colorado, Oklahoma, Texas, Missouri, that we're looking at anywhere here, and even including this part of Iowa, 1 to 4 inches of rainfall. There could be a couple of pockets in there, very, very heavy rainfall. We then want to know, is that going to continue? Is this going to keep going? Because here's the issue. When you look at this map, which shows you the last 30 days of precipitation as a percent of normal, okay, this particular region right now, if you think about it, somewhere being between 0 and 40% of normal, we would need to see about, I think, a grand total of about 4 inches of rain on the driest parts in through here. We need it spread out over a several week time period so as to not cause flooding, and also so as to not allow the atmosphere to dry things out immediately after the rain comes in. The worst case scenario would be a big rainfall event, which looks great in the numbers, but then it gets hot and windy after that and erases most of the gains. We need routine precipitation. So that's the question I'm trying to ask for this area. Again, we've covered what's gone on in the west with the lack of that subtropical jet stream flow, and you're going to see the latest long-range update in a minute and what it means for the west. But here's what we need to do. I went through the whole of the Great Plains, and I wanted to know in April, going back to 1970, what each April's precipitation has looked like. Okay, generally speaking, the precipitation trend is flat since 1970. That's the blue line in the background. Then what I did with this is I ordered the list. I went and ranked them wettest to driest, and then I flipped it around and made it driest to wettest. And I want to show you what I've learned from this. All right. First of all, if we are going to have dry, if it's going to stay dry, and here's the years listed out that were dry in April. A ridge across the west coast and a deep trough that kind of anchors from the Canadian archipelago down to the Great Lakes is what you need. And the reason why is because the flow comes over the top out of the northwest like it has done so much this winter. And as you've heard me kind of show you before, you get convergence in the jet stream. You don't draw on the moisture from the Gulf of Mexico. We generally produce high pressure in this area, and that limits our chances of precipitation. So we start to ask, well, what gives us this deeper trough into the east? Does it have anything to do with ocean temperatures? Well, in spring, which is typically a transition month, there's not a strong correlation with ocean temperatures. You could say that some of these years were dominated by a developing El Nino and positive PDO, but it is not a dominant signal. I want to be very clear on that. Ocean temperatures in spring are not a dominant signal. In other words, when you think about El Nino or the PDO and all these different things, their greatest influence is in mid-season for the hottest and coldest seasons, so summer and winter. I'll prove this point to you in just a few seconds. Next, I wanted to know about what the MJO needed to be doing, and this is what I saw. If the MJO spends some time in the Indian Ocean and doesn't come out over here into the West Pacific, it tended to lead to a pattern that produced those drier conditions across the United States. That seems to be what the MJO signal is out of this. Now let's do the opposite. Let's look at the wettest years. In the wettest years, it makes sense. You got to have a four corners trough. The jet stream has to come flying over this ridge in the Gulf of Alaska, then dive. And then it ejects right in through here. That runs up over a weak ridge over the southeast and just pulls in all that moisture. Look at what we now have between the Canadian archipelago and the Great Lakes. We have a ridge there. So you see, it's almost the polar opposite of that particular pattern right in our immediate vicinity here. So what gets us there, again, it's not a strong signal in ocean temperatures. You could say that if we do have a little bit of cool water here and here, which we do now, that would help. But it is not. This is not going to be the major driver. What I think it's going to be is what happens with the MJO. Because on those years when we tended to do really well with April precipitation, the MJO could get out of the Indian Ocean, get past Australia, and set up somewhere in the Pacific. And we got to ask, is it going to do that? So let's take a look. The current forecast for the MJO, remember last time it was forecast to sweep out here. Instead, it collapsed back into null space and popped back out now into early March. It's currently sitting over the Indian Ocean in phase 3. Look at what some of the models are doing. They're bringing it through and having it collapse again. If we were going to bust through that drought, change the jet stream pattern, deliver the southwest flow, you need to see the MJO go from where it is right now and sweep all the way around like this. Way out here, coming out to phase 7, 8, and 1. And what we're seeing right now is that the MJO is coming back in, and if it collapses back in here, I think its best chances to emerge back over the Indian Ocean. Long story short, if the MJO stays in this vicinity instead of here, that increases drought risk. And you say, why? Well, when you look over there at phase 4, this is where you have that deeper trough. There's a ridge just off the coast, so the flow comes over it and dives like this and then ejects. So what happens is that in the plains, you have convergent flow aloft. It then becomes divergent once you get into the mid-south to New England. So we are, I'll put a label on it, we're dry here and then much wetter to the east. But if we are capable of doing like we did last year, now take a look at this. I know I should graph this, but I'm just going to show you the data. This is 2021 in April, okay, right here. It came through phases 6, 7, 8, and 1. And that's what broke everything down a year ago, delivering the better moisture. So we look at all of that and say, what did the new model runs suggest? All right, see the trough we have right now? That's the one that's helping. See where it is? It's helping deliver the moisture here, which we need right now. As we go forward, this is kind of a 1 week sliding window. We get out here to the beginning of April, and what do we see? The jet stream sweeps around and then dives here. So that means we go over to a drier time period where we have convergence. The flow then comes around the trough and all the action's east. We've got to get rid of this trough, and we've got to develop troughing there. So we keep playing. As we go out here into the beginning of April, there seems to be some signal. See, there's something going on with lower heights. But I need a stronger signal of this getting farther to the south. Without that, it does not put the right flow into the mountains, which ejects into the southern plains and produces these big storm systems. And even though we do develop some sense of a southeastern ridge, this is not yet being fully advertised in the models as delivering what we need to cure the drought. So if I zoom in here and just show you the United States, and we click on precipitation over the next 30 days, and let's just look at the whole month of April. There it is. We once again see this area showing up drier, with the heaviest rains coming out of the northern plains into the Great Lakes, right on the Mississippi River, where we already have flooding here and all the way down the Mississippi, and we're about ready to get a whole bunch more rain on that area. And it's all east. And that's what happens when the flow comes in like that. We're wet in the northwest, drier in California. There's convergent flow here, divergent flow there, and that's where the action is. So I'm explaining to you why the models are looking the way they're looking and showing you the one caveat to this. In my opinion, this might be the most important thing. If that MJO, which is here, if it does not do this is your most critical thing to watch, and it pops out, that's our best signal for returning better moisture to the Central Plains. I think that's the most dominant signal at this point. Now we have a system that's coming through right now, despite the MJO being over here. Okay, we've got a system in place, and that can still happen. We need to go look at what that system's going to do, though. So currently, our all hazards weather map, recording this kind of late this evening, we have a lot of wind warnings and red flag warnings down here with a blizzard warning right now in the middle part of Kansas. And if we just kind of take a look at what's going on here, I was watching this on satellite, you can see this first of two tight lows kind of curling up here. So we got the snow on this side and the severe storms to the south. And that's where we've been worried about severe storms coming over the Red River Valley of the South, extending into Louisiana. That would be the risk tonight. But as I show you this, look at all the dust on the back side of this. You can see it coming out here in New Mexico. It's coming all the way down into Texas. And that dust is substantial. And then after the sun sets and we see the infrared imagery, you can now see the fires that are here. So the red flag warnings were well warranted in this area. So where's it going? Well, tonight, this is our severe weather risk area. Tomorrow, this moves a bit further east with the system. And then we get into Saturday, and now it's over here along the East Coast. And this is just from the first of these two big systems coming through. So I'd like to show you that one in a bit more detail. All right, using the 18Z run, that's why we have the blizzard conditions here. Very strong winds on the backside and the snow that's coming around the backside of this first low. So what we're going to watch this evening is these storms to blow up into this area, and that's going to extend from the Red River Valley of the South down into Louisiana. Going into tomorrow morning, the low is sitting here, so there could be a band of snow through Iowa, southern Wisconsin, right in through this area through tomorrow morning. Heavier rain spreading across Illinois, and the main leading front, this is actually an upper level front. The cold front's way back here. It's still pushing those showers and storms farther to the east, and so that's where we saw that severe weather threat moving east. So it's coming out of Mississippi tomorrow, going through Alabama. See that squall line? And then eventually into Georgia. That's the risk area tomorrow. Then in the overnight hours, that front finally catches up, and here it is by Saturday. The low curls up into the eastern Great Lakes, showers on the backside of it, and a shot at some colder air. And that system moves through New England, and the next system comes into the west. So if I show you that one in the west, here's the frontal boundary on Friday night sweeping through. Watch the west now. And that's going to be the initiation point right here over the four corners for our next system. Now I'd like to show you the next system, but bring up to speed on something we talked about last time, model performance. What happened in the last few days? The GFS dropped off again, while the Europeans stayed the better performer. And we were talking about this happening. Remember the separation in the models? Now we're going to see it again. Our multi-model analysis, GFS on the left, European on the right. Now this first system we've already seen, and the models have good agreement on it. See what they're doing with the same thing here, pulling that one into New England. Now, in the GFS versus the European, see how the European's slower with the advancement of the next front? It's already cleared Idaho, getting into Wyoming and Utah. It's a bit slower in the European, and that's typical. So what we end up getting here is that if you look at the difference between Monday night, we've already got the low fully ejected right here over the panhandles. The severe weather threat curling around us. This is where our severe weather threat's going to be on Monday. Heavy snows back here in Colorado. The European's a bit slower. It brings it out a little bit later. See that? So we open up a large dry sector here with the GFS, and it's more reserved in the European, all based on the timing and the depth of that wave. So then what happens by Tuesday midday, getting into Tuesday evening, this will now be the area, the Mid-South into the lower Mississippi River Valley, that we're going to watch for severe storms. But notice the difference in the characteristics between these two storms out there by next Tuesday evening. Well, as they keep moving across the country, notice how much farther to the north the moisture extends in the European, with a much more, it's almost like a more amplified wave here versus the GFS, which is already starting to show some signs of losing it. It's got the storms coming through the southeast, so if I just highlight this again, Monday, Tuesday, Wednesday, the severe weather threat next week, then this system pulls on through New England, just like that. Now what's interesting is there's a second shortwave that shows up here on Thursday. And that second shortwave is going to kick off another low that's going to soak the mid-Atlantic late next week before this system curls up through New England. So we put all that together, and we're going to primarily focus on the European model, but I want to show you the differences. What do we get? Well, the GFS is in these colors when it's wetter. So Tennessee, Kentucky, you're not rooting for the GFS. You want the European to get this right because we've already got flooding in this area. But back here in Colorado, Kansas, Nebraska, that's where the GFS brings the wave in sooner, farther to the north, and delivers more rainfall. And to the south, where you have all the greens and blues, that's where the European model is wetter. So that's why I show you the model differences, so we can gauge how the systems perform, how the forecasts perform in predicting these systems. But I've shown you the better skill scores with the European. So you look over the next 7 days, more snow coming into this area with that next system, potentially some heavy snow here in the high plains of parts of Kansas and Colorado. Could extend here with the first system, right? But total precipitation is captured well right here, I think, by the European model. So pause it, have a close look, but there's a large section in through here of way better than an inch of rain. We need to get more systems coming into the northern plains to bring more precipitation into this area. That is desperately needed, as it is in California too. I want to show you one other thing here. This is a map showing you the probability of getting 2 inches of rainfall over the next 10 days. So again, with this next big system rolling through, plus what we're getting in the next 24 hours, this area through here has got better than a 70% chance of picking up more than 2 inches of rainfall. This is going to beat back some of the drought, but we need a lot more than this in order to really make improvements. Okay, as we finish it up, let's look at week 2. Temperatures, South American will be done. Notice the pattern going into week 2. The trough is here, and we know that that produces convergence here, so we're drier. Because this trough is not deep enough, California will be drier as well. Now I want you to notice something though. This is only in the European model, not in the GFS. As we start April, the model is attempting to dig a broad trough here. Now if this were to happen, and it's too far out for me to pin this down, but if this were to happen, this would be a signal that maybe the MJO either curls up into phase 5 or 6 or becomes less of a factor, because everybody in the plains would love to see this. We'd have systems that could potentially eject as far north as Montana, the southern Canadian prairie, into the central plains and all the way down to Texas. Is it one that tends to set off a lot of severe weather in the south? It is. So we need to watch the end of this month and the beginning of April for that. But that's getting out beyond 2 weeks. What we see right now is the effect of the convergence, drying things out after these next 2 systems roll through. All right. Temperatures. This is where we expect to see a frost over the next 7 days, everywhere that's shaded into gray. Okay. So let's go look at the high temperatures now that we've seen that map. We've already measured Thursday's highs, so let's now get into Friday. A little bit of cool air behind this first system. The warmth is in New England. And then as we get into Saturday and Sunday and Monday, that's when the warm sector of the next system really opens up. So Sunday's going to be very mild up here in South Dakota, Minnesota, Iowa. Now, as that next system rolls through, that's where the colder air arrives. So we go into Monday, Tuesday, and Wednesday, and then we have pretty extensive cold air that tries to come down here into parts of, the high plains of Colorado, New Mexico, into Texas. In fact, we even look out there day 5 through 10, and we notice where the ridge will be. It'll be in the west, where we're going to have much above average temperatures here. But this was that cool down we were talking about possibly happening toward the end of the month. So now you can start to see it showing up here inside this region. Day 10 through 15, though, remember we saw the pattern trying to do something a bit more like this. So it might be cool into New England as we start the new month. But again, this is too much convergent flow here to really bring in cooler air, unsettled weather with more precipitation. Okay, last thing I want to cover for you is South America. When we look out here over the next couple of weeks, with the MJO curling through the Indian Ocean, that just gives us a little bit of a drier signal farther to the north. We're bringing in the wettest weather right here into southern Brazil, Paraguay, northern Argentina. Now, this is an area that as of late has seen better precipitation. And as we slide this through in a 1 week window, all the way out there looking at week 2, which is almost at the end of this animation. Again, we see the heaviest rains where we were in drought. If we go back over a bit drier in Argentina, this is not a problem given the rains that just went through here. What we need to watch carefully is to see if this area continues to show drier signals into the month of April. An MJO position of phase 5 would make that happen. Okay, so last thing I'll show you is European weeklies, and let's go out there and look at the whole month of April, and this is what we've got. And overall, if this were to verify, this is not going to put a lot of stress on the safrinha crop at this point. But what we need to see is if this region does continue to stay drier, and that would happen should the MJO go into phase 5, possibly collapse and come back out into the Indian Ocean. That's going to be critical to watch. Okay, appreciate all your time tonight, and I'll talk to you again on Monday. Have a good rest of your week and weekend. Thanks.